Hi friends, today we are going to discuss about the Ridge Regression L2 regularization algorithm in Python. So, in previous lecture I already explained clearly about the linear regression with practical. So, here also I am explaining in the Ridge regression with the help of the Python programming on this Boston house price dataset. So, here Ridge regression, which is an extension of this linear regression, where the loss function is modified to minimize the complexity of the model. So, in linear regression, the cost function is 1 by n sigma I is equal to 1 to n yi minus yi hat whole square. So, means we have to, this is the error. So, in this loss function we have to be modified. So, extension to the, we have to add the some kind of parameters. So, what we are going to add? So, the modifications is done by adding the penalty parameter. So, that is equivalent to the squares of the magnitude of the coefficients. So, which means that, so y hat is equal to mx plus b. If it is multiple features m1 x1 plus m2 x2 plus m3 x3 plus b. So, these are the m1, m2, m3. So, these are the three coefficients with respect to the three input features. So, here squares of the magnitude of the coefficients. So, which means we have to be sigma I is equal to 1 to n m1 square plus m2 square plus m3 square. So, we are supposed to add to this summation with multiplied with this alpha. So, the formula here Ridge regression is the cost function of the linear regression. So, the cost function is nothing but like this. So, 1 by n sigma I is equal to 1 to n yi minus yi hat whole square plus alpha. So, alpha means you can take like this lambda value and multiplied with the summation of I is equal to 1 to n so y equal to 1 to n m1 square plus m2 square plus m3 square like that. So, this is the equation. So, here alpha is the parameter, this parameter value we are supposed to select. So, the coefficients of the parameter can be approached to 0, which means the coefficient means this is the m1, m2, m3. So, these are the coefficient parameter can shrink to 0, but never become to 0. So, a low alpha value can lead to the overfitting and high alpha value can lead to this underfitting. So, here alpha value can supposed to take between from 0 to any positive integer. So, if you take small value, you can get overfitting. So, overfitting means you are getting the a more test error, and underfitting means you are getting the high training error and high testing error. So, both errors are high in underfitting. Overfitting means training error is less and testing error is more. Now, we will look into the practical section. So, I am importing the basic libraries pandas, numpy, matplotlib, c1. So, here I am taking the Boston housing.csv file. So, this is the data set. So, this is the statistical information of the data set can be observed through this describe method, and shape is the 506 observations, 14 columns, and there is no null values, and divide the given data into independent variable and dependent variable, and this is my independent data, and this is my dependent data. So after dividing my data into x and y, now I have to again to divide it into training data and testing data. So with this train test split method, so my test size is 0.2, which means my test size is 20%. Now I am importing the ridge regression. So from sklearn.linear underscore model, importing the ridge, then train the model. So while training the model, I am giving the alpha value. So here alpha value I was chosen. So I am choosing the 0.01. After choosing the alpha value, so fit my model on the training data. So ridge regression penalize the model. So based on the sum of the squares of the magnitude of the coefficients. So the regularization term is given by this lambda is multiplied with this sum of the magnitude of the sum of the squares of the magnitude. So here alpha is the shrinking factor, and this is also known as the hyperparameter that varies between 0 to any positive integer. So after training my model here with this alpha value 0.01, so I will check my training score. My train score is 76.99. So after getting the training score, now I will check the test score. So before going to check the test score, first I have to predict my some data. So RR is my model. Apply the predict method on the X test, you will get the predicted data. So when you pass this, when you want to find the R2 score on the Y test and Y predict, you will get the accuracy R2 score is 57.84. So as we increase the value of alpha, so the magnitude of the coefficients are decreasing. So alpha value is supposed to increasing, the magnitude of the coefficient values are decreasing. So where the values reaches to 0, so the coefficient values will be reaches to 0 but never becomes to 0. So which means our m1 x1 plus m2 x2 plus m3 x3 plus b. So these are the coefficients m1, m2, mc. So these coefficient values can be decrease when this alpha value is increasing. So alpha value is increasing, the m1, m2 values are decreasing. So these values will be decreasing but never becomes 0. So then I will import my metrics, mean absolute error, mean square error and root mean square error. So I will apply the metrics on this test data. So 3.78 is mean absolute error, 34.06 is my mean square error, 5.83 is my root mean square error. So here my R2 score is very less compared to this training data set. So now here I am creating my data frame with the help of this actual values and predicted values. So this is my actual values, means my target variable of the data set, and predicted is my model values. So my model is predicted the values, and this is the variance. So if you want to see the observation 13 is the actual value 20.4, but model is predicted 19.20. So now let's see how this value are predicted by our model. So here what I am doing, I am importing my data frame of first 15 observations. So 14 observations from 0 to 13 means 14. So my here index 13th index, my actual target value is 20.4. See, my 13th index, my target variable is 20.4. So if I passing these values to my model, here we will get the predicted values. See here my model predicted the 19.200, which is same as like this. So if I see my intercept, and these are my coefficients. So coefficients means how many input features are there here. My input is 1 2 3 4 5 6 7 8 9 10 11 12 13. 13 input features means 13 coefficient values are came. So our equation is y is equal to mx plus b, mi xi plus b. So here xi values are 13, so that's why you are getting the m1, m2, m3, m4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 coefficients, and this is the intercept value. So if you want to see, so this is my features. So this is my m1 corresponding to this feature x1 CRIM. So for this input feature, this is the corresponding coefficient values. So when the coefficients, when the alpha value is 0.1, so whenever this alpha value is going to increase, this coefficients values becomes decrease but never becomes 0. So this is the graph. In this graph, so here the my original labels are green color. So this is my actual values are this green color, it can be scattered, and my predicted values are red color, is scattered also. So this is the diagram, how our actual values and predicted values will be scattered. So this is the graph about the actual values are the scattered, but the more predicted values are the plotted with this red color. So in this graph, so both original values means actual values and predicted values are be plotted. So here, if you want to observe the coefficient values through this bar chart, so here in this graph, in this bar graph, so this is the 0. So from 0 to above, this is the positive. From 0 to downside, it is a negative. So here this is the x1, x2, x3, x4, x5, like that up to x13. So here, so this side are the positive values, and from this side are the downside are the negative values. So through this diagram you can observe clearly, so which coefficient values are giving the more coefficient values. So this is the x4 means CAHS feature giving the 2.5 value. So this is the m1, m2, m3, m4. So m4 value is about to 2.5. So this is the x6 feature. So that is the rm. This value is about to 5. So this feature has the minus 15. So through this bar graph, we can observe clearly the coefficient values with corresponding to this input features. So the same thing you can get this in this graph also, but thing is difference is, so the coefficient, the graphs are displayed with different colors. That is the only difference. So here I am importing the pickle file. Through with the help of the pickle file, save my model. So if I pass to for predicting this input features through my saved model, so you will get this output value like this. Okay, so here, so this is the result we got when you select the alpha value 0.01. So at which alpha value our results will get more better means we can't able to say. You have to trial and error manually, you have to give the values. So if you want to suppose at a time, you can suppose to give the alpha values to figure out what alpha value is good for our model. So we don't know, nobody can say at what alpha value we are giving the best result. Nobody will say until execute. So we will definite multiple values and check the performance accuracy. So here I am taking the some alpha values from 0.001, 0.01, 0.01, 0.1, like 110. So first let me execute this one. So then in this here, if I given the alpha value 0.01, so my train score is 0.7698, my R2 score is 0.5785, so mean absolute error, mean square error, and this is the root mean square error. So in this in 31st cell code, so with single kind of cell code you will get the multiple results at a time. So when you pass this alpha, all values of these alpha values 1 2 3 4 5 6 7 8 9, so 9 alpha values are passed at a time, so you will get the results at a time. So when alpha value is 0.01, this is the result. When alpha value is 10, this is the result. So you can compare which is the best score. So while comparing, we can able to select those alpha values. So those alpha value is the best alpha value for giving the best result. So which means that, so alpha value play a key role. The model is not overfitting, not underfitting. If you take this alpha value, a small value, what happen? If you take the small alpha value, your model will be overfit. If you take big alpha value, your model will be underfit. So without getting overfitting, underfitting, you can suppose to select the best alpha value, means optimum alpha value. So best optimum alpha value, you are giving the generalized model. So generalized model means the model is properly trained well on this training data and testing data, which means that whenever create a model, that model is a regression or classification, we need to create the generalized model, which means best model, which means that low bias and low variance. So the main intention of this ridge regression is to reduce the overfitting, and to reduce the model complexity. So this is the way we can execute the ridge regression in the Python programming language. I hope you understand this concept clearly. Thank you.